Hey everyone, welcome to Code Harmony. Today we are going to solve this question 1752. Check if array is sorted and rotated. This question has been asked in Google recently couple of times and all the other good companies, and this is based out of array. It's one of the standard problem from array topic. Let's have a look on the problem statement. We are given an array nums. We have to return true if the array was originally sorted in non-decreasing order and then it got rotated by some positions including 0. It means that array was initially non-decreasing order, sorted 1, 2, 2, 3. Then after that it might be sorted, rotated by some position. Let's say I rotate by 2 position, it will be 2, 3, 1, 2. So if that is the case, we have to return true, otherwise return false. There may be duplicates in the original array. That's why they are saying non-decreasing order. Apart from that, they have also given this note. An array A is rotated by X positions if the and resultant array is B. Such that, okay, they are just giving you the formula to rotate an array. And if the array A is given to you and you have to rotate that array to B, you have to do something like this. Array A is given to us. Array A is something like this: 1, 2, 2, 3. And we have to rotate this array by X positions. Initially the indices were 0, 1, 2, 3. So in the final array B will look like this. B is going to look like this. So for B, the index is going to be I plus X, because we have to rotate by X position. So initially I am just capture this, then I will just capture this. Firstly I plus X, 0 plus 2, which is 2. This I have captured. And now 1 plus 2, which is 3. This I have captured. When I am just coming to capture next position is this, which is I plus X. These indices are something like this: 0, 1, 2, 3. So it is 2 plus X. 2 plus X is 2 plus 2, which is 4. That's why we are taking modulo with number of elements in the array, modulo with n. So I plus X modulo n is going to give us the relative position in the initial array. So this 2 will be pointing to the 4, modulo 4, which is 0. So this 0 position is coming here and this 2 is coming here. So in this way we generally create our rotated array. So it will be I plus X modulo n in the B array. So initial array is I. Okay, so this formula is they are giving. A of I is equal to B of I plus X modulo n, and modulo is the modulo operator. This is just their note. Okay, now return to the exact problem statement. See, first of all, what is given to us? We are given an array which they are saying that might be the case that this array is sorted and rotated. You just have to validate whether it is from this case or not. This array of integer is given to us. We have to check whether this array is sorted in non-decreasing order and rotated. What we will be returning? Either true or false. This is something we have to do. What should be our approach in this case? Let's firstly discuss about the brute force. Checking with all the possibilities. Let's say this array is given to us 3, 4, 5, 1, 2. This array is rotated by X position. If we just rotate it one by one and see whether at any moment we are getting a sorted array or not. If we just check 5 possibilities in this case, and every 5 possibility we are just rotating this array and checking whether it is sorted or not. Moving 3 to the left, it will look like this: 4, 5, 1, 2, 3. No, this is not sorted. Move 4 to the left, right. This is also not sorted. Now move 5 to the right, 1, 2, 3, 4, 5. This time it is sorted. Checking all the possibilities. But in this case, our time will go exponential. So this is not accepted. And the second brute force that is coming to my mind is compare with sorted array. In the second approach, the array given to us is this. The array which is already sorted is this. We can compare these two arrays. how we can do that? Let's say the first array is having index I, second array is having index j. So both are initially 0, and then we'll maintain some kind of offset, or we'll just consider at the rotation. Let's say the firstly having a rotation of 0. It means we are comparing all the array like it is already given. If I just mention I is equal to 0 plus 1, so it means I is starting from 1 and this is starting from this position. Then we can just compare it. And how we are going to compare? We'll just take modulo of I with n, so that the rotation will automatically handle. So in this case also it is not sorted, not matching. Now what we are going to do? We are just going to increment the rotation pointer. Let's say I am starting with 2. If I start with 2, it will be pointing to 5, and this is pointing to 1. In this case also it is not matching. Just undo this. And now start with 3. 3, if it is 3, if I is equal to 3, then I is starting from this position and j is pointing to this position, and we can keep on incrementing both the pointer for 5 times to just to incorporate the length of the array. And every time we are also going to take modulo of n, so that I equal to 3. Initially I equal to 3, then I equal to 4, and then for 5 it is 0, because the length of the array is 5. So this is another possibility, that compare with the sorted array. But in this case also we are going to utilize n square time, which is not affordable because we have to do it in a better time. So these are the two possibilities, checking all the possibility and see whether that is sorted or not. That's sorted or not we can just compare by doing one iteration. And in this case we are comparing it with a already sorted array, but both are giving us quadratic time. Now let's try to build our approach, which is going to run in order of n time. This is the enums array given to us. If it is sorted and rotated, the shape will look like this. If it is a valid array, let's say if it is yes, it is valid, it will definitely look like this. The one portion is increasing, and then there might be the portion that initial section is mapped at the end of the array, like this. So in this case, this 1 2 was present at this position, and then it is moved to the later position after 5. So this should be the state if we have done this kind of operation, like rotated and sorted. If we are able to form this kind of structure, that if I just pick the second element, pick this element and move it to the initial position, it will look like this. It is able to form a single linear array. Then it is fine. Then it means that this is a valid one. Now okay, now just if I just do one modification, 3 4 5 1 2 3 4 5 1 2 7. In this case if I just have a look, this is 3, and now this is 4, this is 5. Okay, and now if I just take 1 and 2, where is 1? Where the 1 will come? 1 will come here, and then 2 will come here, and the 7 will come here. We can't shift this second portion to the left. It means these two yellow lines you should take care that only this portion is allowed to be shifted at this position. This 7 is coming into picture, which is crossing the existing elements. It means this is not sorted. This is rotated, but this is not sorted. So like, I hope you are able to understand that only this portion in the blue line in this quarter is going to move to this quarter, because this yellow line is something which is maintaining this partition, which is at which the array is getting partition. So this 7, presence of this 7 is not going to make it a valid array. Okay, so if I just try to give you an example, the array should look like this. This is one array and this is also one array, and now this is something you have done the rotation. At this position you have done the rotation. So what will happen in this case? If I just draw a couple of lines, this portion will shift to this side. Okay, so this happen when we rotate this array. So if this is a valid position, we just have to figure out whether this is possible or not. It means that let's say the array is something like this: 3, 4, or let's say this is 5, and this is 1, and this is 2, and this is 3. In this portion, at one position from 5 to 1, there is one downfall, one fall from this position, and from 3 to 3, no, there is no fall. So if only there is one fall, then it is valid, otherwise it is not valid. Now let's see another case. The array was something like 3, 4, 5, 1, 2, 3. If the array is something like this, 3, 4, 5, this is coming here, 1, 2, 3, this is coming here, and if I just insert 9 at the end, so the 9 will go till this position. So in this moment, what we are going to have is from 5 to 1, there is one fall. From 9 to 3, it means this 9 to 3. We also have to check the rotation. From 9 to 3, there is also one fall. Okay, so in this case, this is not sorted. So first of all, let's don't worry about this edge case where I have just taken this 9. You just see one thing, that at any moment our array is increasing. Our array is increasing, not increasing, it's non-decreasing. Array is non-decreasing. Then at any moment you will encounter some kind of like this fall, and then again it is non-decreasing. So this is something that you have to validate. It is non-decreasing, and then one fall is allowed, then again non-decreasing. So in this case, if you just counter how many falls you have encountered, it was non-decreasing, then there is a fall, then non-decreasing. It means that for this I position, or let's say the I position is at this, for this I position, let's say this is the I position and this is I minus 1 position. The I minus position is greater than I position. If I do something like this, for I equal to 1, I'm starting from 1 because I need to take care of I minus 1 as well. From 1 to n minus 1. If at any moment in element at I is less than element at I minus 1, it means that this is a fall. This is a downfall. Okay, and we are allowed to have only one downfall. Fall plus plus. This is something you need to capture. Okay, from index, let's say 3, 4, 1, 2. In this case, this is 3, this is 4, this is 1, this is 2. 3, 4, there is fall, 1, 2. You have just encountered this. If in the end, if fall is less than equal to 1, then return true. Otherwise you have to return false. If let's say there are 2 falls, 1, 2, 1, 2, 1, 2. In this case, this is not sorted and rotated. There is multiple falls. It means it was not sorted initially. So this much you have to do. For I equal to 1 to n minus 1, every I position, I plus 1, I minus 1 you have to capture. Whether the I minus 1 is greater than the current I, it means there is a fall. But what about the situation where let's say the array is something like this: 3, 4, 1, 2 and 7. 3 4 1 2 7. 3 4 1 2 7, it means it will go till 7. This is missing because we are not considering the 0th one and the n minus 1th index. Okay, so from 0 to n minus 1 there should also not be any fall. It means if there is a quarter, if one portion is coming in this section, the second portion should not cross this line, this horizon line. It should be like this. So that's why we have to compare this position with this position as well. So that if this is, let's call it n minus 1 and this is 0, the n minus 1 should also not be greater than 0. Otherwise it is not a valid one. So you can add one more condition. If n minus 1 is greater than 0, you can just say fall is increasing again. If it is going till this, so it is falling from here to here. So this is going to be the logic, and in this case what we are doing, we are just iterating over the array from left to right, and for every ith position we are comparing it with I minus 1. So this is what we are doing. And now what will be the time complexity? Time complexity will be in the order of n, and about the space complexity is constant. Let's code this problem. First of all, let's capture the size of this nums array. Nums dot length. What if the size is less than 2? If n is less than 2, in that case we can directly return true. It's already sorted. Then we just have to capture the fall count, and that count will be something like when ith item is less than the I minus 1th item. For integer, I'm starting with I equal to 1, I less than n, I plus. Okay, if nums of I is less than nums of I minus 1, if it is less than I minus 1, it means there is a fall, and that for that I need to increment this pointer, and we are allowed to have only one fall in this case. Okay, so yeah, this much we have to calculate, and in the end if fall is less than equal to 1, in that case it is true, otherwise return false. We also need to check the corner case where the n minus 1 item, if nums n minus 1 item is greater than the nums of 0. This should also be not be the case. The num minus 1, the last item, if it is rotated, the last item at least should be equal to nums of 0. Whatever in the diagram I was showing, that should not cross the horizon line. In that case we'll just increment the fall plus. This much we have to do. Let's run over sample test cases. Sample test cases are passed. I'm submitting the problem. It's submitted successfully. I hope you understood the approach. If you have any doubt, you can comment below. Thank you guys. Bye bye.